for Lectures for Introduction to Geology. This video is about texture. So igneous rocks are classified into two major groups, texture and composition. And today we're going to talk about texture. And basically every rock tells you a story, and igneous rocks are no different. And they have two major kind of storytellers involved in their classification. One is talking about the viscosity of the magma, which is in turn equal to how dangerous the eruption style might be. And then the other one is based on whether or not the magma made it close or to the Earth's surface. And that's what we're going to talk about today, is texture. And texture is essentially how big are the individual crystals in the igneous rock? Can you see individual crystals, or are they microscopic, right? And when we look at these igneous rocks, we're trying to decide, are they intrusive? Did they crystallize deep underground? And the way I remember this is intrusive cools inside of the Earth, right? Also known as, or commonly known as, plutonic. And those are big visible crystals. You can make out individual mineral grains. You can see individual minerals. Versus extrusive, where they crystallized at or very near the Earth's surface, right? Extrusive extrudes from the Earth. And these are also known as volcanic rocks, right? They have little tiny microscopic crystals. Still form crystals, but they're tiny. And in an earlier video, we talked about magma, and the magma that makes it to the Earth's surface, we call that lava, right? And you know, you start to ask yourself questions like, why do we find intrusive rocks in the field, like at the Earth's surface, if they cooled below the Earth's surface? Shouldn't they be buried deep underground? And we can attribute that to erosion, which we'll talk about in sedimentary rocks, weathering and erosion section. And then why does contact with the surface change how a magma crystallizes? And the answer to that question gets at how quickly things crystallize, right? And the Earth and the crust is kind of like a blanket, and it has an ability to insulate these cooling magmas from the much cooler surface, right? And doesn't, and the difference between temperature is big enough that, you know, the weather conditions don't play as big as a factor as how deep you are under this blanket of our crust. And then finally, you know, where would you expect magma to cool quickly? And like we mentioned, near the surface, right? And so here's a depiction of the environments where we see extrusive versus intrusive rock forming. And we would expect to see intrusive rock forming in this magma chamber, this pluton deep under the Earth here. And then near the surface, we see active extrusive rocks being made. As this volcano is erupting, it's extruding lava. It's extruding magma that makes it to the surface lava. And it's making these extrusive igneous rocks in the process. Very fine, tiny crystals, right? So this texture term is all about the appearance of the rock based on the size of the mineral grains, the crystals. And that crystal size is mostly controlled by how quickly those crystals cooled. The big crystals had time to grow slowly under the blanket of Earth. They're warm and comfortable. They have time to cool slowly and grow big, right? Versus a very quick cooling, which creates small crystals near the Earth's surface. And then, you know, other things come into play here. The amount of available silica can change how big the crystals get. Less silica allows for lower viscosity, which can be more growth in some cases. And dissolved gases also can play a role. And here are two extreme ends of the spectrum. This is a aphanitic, also known as a fine-grained, so an extrusive igneous rock. Notice that you can't make out individual crystal grains. It's microcrystalline, right? Microscopic crystals. Extrusive, also known as a volcanic. igneous rock. And then here is a phaneritic, a coarse grain, very large, visible, individual crystals that you can make out. You can see in this picture, there's quartz, some K feldspar, some plagioclase, very visible to the naked eye, right? Slow cooling, large visible crystals. This is an intrusive, also known as plutonic igneous rock. And then you can have extreme variations on that. Here's a Hanlon's for scale. This is a pegmatitic texture. So pegmatites, very large crystals. You can get extremely large crystals in some cases with the right conditions, with certain gas and cooling history conditions. And then you can have variations on that, where you have a porphyritic texture, where you have large, what's known as phenocrysts floating in a microcrystalline matrix, right? And this can be explained by a transition of cooling environments or just various compositions. It can get fairly complicated with these porphyritic textures. But generally, my rule of thumb, and there's some argument on what exactly defines a porphyritic texture, because some people might argue if you have two very different crystal sizes, like large crystals and smaller visible crystals, that's a porphyritic rock. But my belief is, and I think this is true, is that you have large crystals in a microcrystalline texture. That is a true porphyritic rock. And then you can get into more specific textural terms, like if you had a really gassy magma that was creating lots of bubbles as the rock was cooling, you get this like Swiss cheese looking rock. And these bubbles are known as vesicles. And we call that a vesicular texture, right? And these are really common in basalts, especially in places like Hawaii and craters of the moon in Idaho, right? You see a lot of these bubbles trapped in the rock, the basalt in that case. And then you can get glassy texture. So if you cool off a lava very quickly, you quench it like into water or something like that, you don't get any time at all for crystals to form, and instead you form a glass, a volcanic glass like obsidian. And even though this glass here is very dark in color, it probably represents a fairly felsic type magma. And we'll talk about felsic as a compositional term to talk about what the rock is made of. We'll talk about that in another lecture. And then you have other types of extrusive rocks that are specific to the type of eruption that they experienced. And these are called pyroclastic rocks. Pyro meaning fire and classic meaning pieces. So fiery pieces, and they signify a violent eruption. You can get like cemented ash, which is known as tuff, and then various ash particles fused with pumice and obsidian. You can get a welded tuff and volcanic breccia, all representing a very violent type eruption. And you can get pumice. We have very frothy magma erupting, or scoria, which represents a fairly vesicular type igneous rock. And there's some pictures of those. And so that brings us to the composition, which we'll talk about in the next lecture. And thank you all for stopping by and listening. And please continue listening, subscribe for the next lectures.